Good afternoon, everybody. I'm Patrick Galbraith, and I appreciate you coming to this talk. This is probably one of the biggest audiences I've had, certainly bigger than last year. But we'll go ahead and get started. I'm Patrick Galbraith. I work for Oracle. I'm on the MySQL as a service team. Just some things about me. I've been in this industry for quite a while. I've started out in tech, well, in 1986 on electronics, but I got into working in software and systems administration around 1993, 94. Found out about this new OS called, some guy called it Linux at the time, and it was, I spent a weekend downloading Slackware onto 26 floppies on my Packard Bell, and I never could get extra on, but it's been a wild ride. And it's kind of interesting being back in Seattle because I really started my tech career here, though I live in New Hampshire now. There used to be these meetings in Ballard at Taki Pizza run by Phil Hughes. He started the Linux Journal. So those were the sweet days. And now we come full circle, and I've been at any number of companies. I'm now at Oracle. I was at Hewlett-Packard prior, Hewlett-Packard Enterprise, Blue Gecko, which was a database company here in Seattle. MySQL, I was there for 3 years, classmates. Slashdot. It's in the US Navy. Interestingly, we were talking about MySQL and Kubernetes. In 1999, I worked at Andover.net. They have a company that owned Slashdot. And there were these two guys, one from Finland, one from Sweden, David Axmark and Monty Vidinius. And they came to talk to us about this thing called replication that we really direly needed for Slashdot. And that's how it all began with MySQL for me. Some things about me, I won't get into it too much because there's a lot of material I have to cover, and I want to touch on Vitess too. I've got so many slides. My big problem is, I used to always worry, do I have enough material to cover in a talk? Well, that's not a problem. So about my team, I was at Oracle Dyn for the last year, and I've recently moved to MySQL as a service. We're building a MySQL service on Oracle's cloud. I'm very excited to be starting on that, working on MySQL again and working with many former colleagues from MySQL days. What is this presentation about? Well, how many of you are Kubernetes users, Kubernetes administrators? Okay. How about MySQL DBAs? Okay, so kind of a mixed group. Sometimes I give this talk and I have to kind of explain what containers are, so I won't get into that as much. But there is this kind of this misconception with MySQL on containers. People, oh, databases on containers, oh, that's really scary. So it's about running MySQL on containers, and in particular MySQL on Kubernetes. It's about stateful applications, and in particular stateful sets. Operators, MySQL Operator, which there are two of them that I will show you, and I'm really going to try to get to my Vitess slides, though there have been many great talks on Vitess here, so I can't touch the quality that Suga can do on talking about it. It's such a great system, it's hard to cover it all, but anyway, so I got a lot of material, and time permitting, if we have questions, I have a number of demos I could play, but there are two primary ones I want to show you. So we'll see how it goes. So I won't get into this. We know what containers are. I often explain, the thing I have seen in numerous places is you see people who start using containers, and to them it's another type of VM. You'll see them run things like supervisor D, and there are all kinds of processes running on the container, and they might even be running Chef. I won't say where I've seen that, but they might be running a bunch of Chef cookbooks inside the container, anti-pattern. But it's a learning process. I did the same thing. So it's often an education thing. And VMs versus containers, this is a slide I always show people to kind of hammer home what the difference is. And when you look at this, you can kind of see, okay, we're actually running on the host OS. There's no hypervisor layer. There's a little, there's some layers that you have to go through, but it's much more, it's part of the OS. It's not so much virtualization as much as it is isolation. I mean, that is a type of virtualization, but it's different than a virtual machine. And I won't go into VMs versus containers. So this is a slide I enjoy. I like this graph that it kind of explained, because you can see the whites in people's eyes when they start, database on container, oh no. It's more of a misconception than reality. And I firmly believe that containers, and in particular Kubernetes, makes it easier to run databases on. It makes it easier to run any application on, I believe. Testing is made easier. No emulation layer. Databases, it's always kind of this question of pets versus cattle. In databases, you think of them more as pets. A pod of multiple databases, database instances, or one. This was something that I discovered when I first started using Kubernetes. I thought, okay, pods are one or more containers on a machine. I thought, I really don't want to run a bunch of MySQL containers, so what does this mean? Because I always try to understand a new technology by how can a database run on it. And in the documentation, Kubernetes pods are mortal. That strikes fear into the heart of a DBA. And a database is a very complex, stateful application. With a database, you want stable access. You want applications to always get the same database handle. You don't want any surprises. And safety, you don't want to scale if it's unhealthy. That's duh. Persistent storage, obviously. Persistent, sticky storage. So really, it boils down to this for me. It's the way I kind of explain it. Database containers are the cattle. The data is the pet. And here's a graphic I'll explain this. So first of all, you have your data. That's the pet. Then you might have a config map or secrets. Then you have your container, and the container runs and it sets things up. It runs. If it crashes, well, we have persistent storage. We're using block storage, or even on the host system. That container might go away, but we'll run another container. It's the same thing as before. And if you're using a stateful set, as I'll show you, it is the same thing. It's like restarting MySQLD. It's within a container. So this is something to help people understand and not be afraid of it. So with Kubernetes and MySQL, I think of it as a tale of two open source projects. MySQL, it's the world's most popular open source database. It's ubiquitous, been around 20 plus years. And then of course there's Kubernetes, the new person on the block. It's the fastest growing open source project. Its application, we know all the things. I don't have to preach to the choir here. And the Borg paper's there for your convenience when you download the slides later, which I put the most current version up last night. I won't say how not ready they were. So Kubernetes ingredients for stateful applications. These are some things that I always think about that really make it much more feasible to run databases and other stateful applications on Kubernetes. We have labels. I mean, that's kind of a basic thing with Kubernetes. It's what allows discovery. It allows things to associate and know where the stable thing is that you need, whether it's storage or network. There's services, obviously. It's the abstraction that lets you connect to an underlying pod. There's kubedns, which is, I worked at Dyn. I still work at, we're part of the same company. And DNS is something people take for granted until it doesn't work. And you want it to work right. And this is something that's built within Kubernetes with kubedns that makes it possible to do some really cool things. Helm charts, of course, you abstract it out a little farther, and you can think of it more as in like an apt package on Kubernetes. Of course, persistent volumes, persistent volume claims, and storage classes. Stateful sets. Some interesting things you can do in stateful sets. Init containers, volume claim templates. I really should kind of have sidecar containers under there, because what I'm going to show you later utilizes this pattern. And then of course we have operators, which takes domain knowledge and codes it into a controller, an application that does something for you that you no longer have to repeatedly do the painful way. And then there is also one thing. You have node selector and affinity. This is something I heard discussed by the fellow from Red Hat this morning, of being able to schedule certain things, such as a database on a certain type of node. So originally, one of my first contributions to to Kubernetes was I submitted an example of how to run Galera. And what it was is it was 3 pods, and each one of those pods had there was also a service, and it was hard-coded. This right here was the pod. This here was the service for the given node, and then this was an overall service for all of the nodes. It was very unflexible, and this was a basic way of understanding. This is a way of seeing how far Kubernetes has come and how much easier it is now to run things like this, and much more dynamic. It's not this thing where you have to think about it. Then, of course, we have another simple way of running MySQL is to run through Helm. And there are a number of different flavors of MySQL and forks of MySQL you can run, and these are 3 of them right here. That's the simplest, but there's so many more advanced ways of running MySQL and easier ways of running. Node selector, as I mentioned, this allows you to specify some affinity and what sort of node you want to run it on. And you can have hard and soft affinity. I haven't used this myself, but it's something that I find really intriguing, and it's an incredibly useful part of Kubernetes. Now we get on to stateful sets. So what are stateful sets? We've heard a lot of discussion as to what they are, and if you don't know, they provide guarantees about ordering and uniqueness of pod resources. Anything that's related to that pod has a stable name, a sticky name throughout restarts, and it allows you to also connect directly to the pod. You don't necessarily need a service to connect to the pod. Like for instance, if you have 3 MySQL servers running a master, 2 slaves, you can connect directly to the master for reads and writes, and to the slaves you can connect read-only, and you can specify those. It also ensures ordinality. When you start it up, it's not like a deployment where it's random. There's also 1 pod per index, and they're not interchangeable, and they won't attempt to run with the same name. They have a stable network identity. This is important with databases in particular, well, with anything really. And it's always named. If you create a headless service, say for instance you have a headless service called MySQL, each node that comes up will be node.mysql. The headless service basically is think of it as creating a zone, a domain name internally for your service. And they're stable across restarts. Also stable storage and stateful resources, across restarts. If your underlying container dies, it comes back up and reattaches to the storage that was associated with that member of the stateful set. And safety, it won't scale if it's unhealthy. That's very good. That's something we want. So here's some animations to explain to you, kind of hammer home the difference. Here's a deployment. So deployment, you have a replica set, creates 1 pod, creates another pod. You notice these aren't in any order, and they're not named with each one doesn't have an ordinal name. Third one could come up in this order, and then of course you could have a crash. Well, there's nothing to prevent another one from popping up. But then we have a stateful set. So this one's called MySQL. First node comes up, second node comes up, third node comes up. Okay, you might have something crash. No problem. It won't scale, and it'll replace it. So these 2 animations, I like to use them as a way. They were actually something that Anthony Ye put together, and I added the animations to it, and they're really good for explaining. It kind of helped me to understand when I was first utilizing stateful sets. So of course I mentioned headless service, and what I mentioned is like creating a domain name for what you're running. And you basically specify them without having a cluster IP. And whoops, I didn't want to go there yet. And for read-only, if you want to do read-only, you create another service if you like, or you can connect directly to the pod since they're consistently named. And then we have storage class and volume claim templates. In this example, we define a storage class named OCI, and it's using Oracle Cloud's block storage. And then within our stateful set, we have a volume claim template where we have an annotation kind of referring to that, and then the storage class name, OCI, and so that when the pod comes up, it'll use that block storage. Here's a very simple example of a stateful set. This was an example that Anthony A. had put together. I keep it around. It's not something you'd necessarily use for production, but it's a pattern you often see. And one of the operators I show, you'll see this pattern. It's 3 nodes. You have a master, and then 2 slaves, and there's a read service that it connects to. And then for writes, you can connect directly to the master. The way it's built is there are 2 init containers. One init container sets up a config map and it sets up a MySQL CNF file, a conf file for MySQL. If it's ordinal 0, it sets it up as the master. If it's anything above 0, it sets it up as the slave. And then there are 2 app containers. One's a sidecar container that runs backups. And again, if it's ordinal 0, what it'll do is it'll create a clone of that first node, and it'll create a netcat so that it's available for the subsequent nodes. Anything greater than ordinal 0, backup will do the restore, and so on and so forth. A very good, that example, if you look at that slide and look at it, it can explain to you how a lot of MySQL operators are done and how the approach that they're taking. Operators, now this, as I mentioned, takes domain knowledge, the things you do as a DBA or as a DevOps engineer. It takes those patterns that you do repetitively, even within Kubernetes prior to there being operators, and allows you to, it builds it into the app. If it's, as I show you here, there will be setting up, there are 2 things that I'm going to show you. One is setting up InnoDB cluster with group replication. The steps that you manually do that, it's a little bit of work, but it does that for you. You don't have to think about it. It's encoded into the application. And another operator which uses Orchestrator, which Press Labs built, that does the same thing. It sets up Orchestrator for you, does all of the tasks you normally do by hand, and it's built into the app, and so you can use it more as an abstraction from what you would normally do if you had to do it manually. Operators extend the Kubernetes API. They create custom resource definitions, such as, here's some examples here: etcd cluster, Prometheus, MySQL cluster. It's not supposed to be a space there. Backup, restore, Oracle, WebLogic, so on and so forth. I'm kind of doing this out of order. It leverages Kubernetes primitives like replica sets and stateful sets and services. As I mentioned, they execute common application tasks, and they're usually installed as a deployment. Here's a good example of what operators do. They observe, analyze, and act. So the observe stage is to look at what there currently is. In this example, there's 2 running pods. One is 3.1.1, one is 3.2.10. And then it analyzes, it says, it does a diff on it, basically. It says, what are the differences from desired config to running config? Well, we should be 3.2.10, and there should be 3 members. And then there's act. So act is going to get the desired config. It's going to recover 1 member, and then it's going to recover any of those that need to be updated to 3.2.10 to that version. I won't play this demo. It's a pretty cool demo. I took doing etcd cluster and bringing it up, and it's probably about a minute. I sped it up quite a bit, but it's a good example of how the operator pattern works, and you can extrapolate that farther for other types of things, more advanced stateful applications. Here's a list of MySQL operators, and 2 of these I'm going to demonstrate. There's the Oracle MySQL operator, and then there's the Press Labs MySQL operator. The Oracle MySQL operator is you're able to deploy highly available MySQL instance onto Kubernetes with a single command. It watches the API server for custom resource definitions related to MySQL cluster and acts on those resources. There's backup and restore, and there's also backup schedule. It utilizes MySQL 8.0, group replication in InnoDB cluster. Has automated backup and restore to and from object storage S3 compatible. In the demonstration I'll show you, it'll be Oracle's block storage, object storage. Here's a kind of an overview of what the operator does. You have the Kubernetes API in the operator, and it interacts with a stateful set running the MySQL cluster. And then within each one of the pods, it's basically set up like this. You have the Kubernetes API, the operator creates CRDs, MySQL cluster, and so on and so forth. And then it ends up running a stateful set, and then within each one of those stateful sets, the pod has an agent and a MySQL database. The operator is acting on what needs to happen and updating the Kubernetes API. And then the agent also is talking to the Kubernetes API, observing what it needs to do. And whatever it needs to do, it does those tasks, such as cloning, doing a backup, doing a restore, setting up the cluster. And then the agent also, as I mentioned, does the restore and the backup, and it does that through streaming to object storage. And here are some simple examples. Since I'm going to do the demo, I won't go into this. Scheduled backup, that's the one thing I do when I show. It's pretty cool. You set a schedule and a cron-like entry for it when you want to run the backup, and set up what storage provider you want to use. Connecting to the Oracle MySQL operator, there's a couple patterns you can utilize. You can write directly to a single pod because it is a stateful set. You can do a read-write-only service if you like. And then, of course, there's the MySQL router pattern, which you'll see in the demonstration. MySQL router is a new feature, a new piece of software, and what it does is it's intelligent about, you can tell it which is going to be the primary and the secondaries, and if you want to pick a node in the cluster to write to and then specify which ones you want to read from, it'll do that for you and proxy your MySQL traffic for you. And often what you do is your application pod, you have that as one of the pods within your application pod, and you connect to localhost within the pod, and that connects you to the database. The demo, so this demo is what it's going to do is create a 3-node cluster created by the Oracle MySQL operator. It's going to show components such as MySQL Operator container and each pod node with the MySQL and each pod's MySQL agent sidecar container. And then there's going to be a WordPress deployment that consists of a WordPress application container and then the MySQL router container. And the WordPress container is going to connect to localhost and inevitably through the database through that. And what I'm going to do is I'm going to show bringing up the WordPress website and doing a backup, doing something really stupid, and doing a restore. I'm also going to show you running external DNS to Oracle Cloud's DNS service. I have a domain, kubernetes-cluster.com, and the website will be set up as that automatically. So I'll go ahead and, oh, good, it's full screen. I'm in presenter view, so it doesn't look the same as over there. All right, so the initial state, we have nothing running. Just checking out Helm. So what we're going to do, we're going to create the operator with Helm. And I've created a namespace called MySQL Operator, and that's where it's going to run. So we have the logs for the operator. I can't see this whole thing. Uh-oh. This is not cool. Actually, you know what I'm going to do? I'm sorry. I'm going to run this from an actual program that runs graphics. Sorry about that. Okay, let me, oops. Let's talk on it. Excuse me, sorry. Okay, I'll just go ahead and start this. Okay, so we have the initial state, as I mentioned before. going to skip ahead a little bit now. I'm just going to leave it alone. Last year, somebody said, you need to resize this and edit it. And I said, I almost started, and I said, no. I get totally off track. So we've created the operator. We're looking at the logs. So now we're going to look at the cluster. We have a config map. We're going to use the default authentication plugin. We have our password and a secret. Now here's our cluster with 3 members. The storage, and now we have to create a service account for this, the MySQL agent sidecar container. So we're going to create a namespace called WordPress. We're going to use that namespace for all subsequent operations. So we're going to create that service account. Now we're going to create the cluster. So you can see the operator churning into action there. It wasn't quite this fast when I originally recorded it, but it is pretty fast. So we're looking at the agent logs for the first node. I have that running, and the window to the left, that's showing the PVCs being bound on Oracle Cloud Block Storage. So I'm just going to log into Kubernetes dashboard and take a look around here while things are coming up. You can see the deployments occurring. See the containers are starting. It looks good thus far. So now we can see the third node coming up. And now the cluster should be there. So what I'm going to do is I'm going to I'll have the operator logs in that top left corner, and then all the rest of the windows will be the agents for 0 through 2. Just so you can see things happen, like when we do backups, like where is the backup going to be scheduled. So the way backups work is that the operator picks out one of the secondary nodes to perform the backup from. The backup is MySQL dump currently only. We are working on enterprise backup, and we do have an architecture that allows you to have different types of backup providers. So here's the WordPress container pod, deployment, and we're going to specify the DB host. It's localhost 6446. We also are going to create external DNS deployment. This is going to connect to the Oracle Cloud DNS service. And I'm also going to load a secret from a file here. I'm not showing you that file. So we're going to create that now. And I'm going to watch the logs. This will be interesting because you can see when as the deployment for WordPress comes up, you'll see it's connected to Oracle Cloud Service now. Now we're going to create the WordPress deployment. As I mentioned, this is going to run MySQL router and WordPress. And it also sets a domain host name for the WordPress service we're running, www.kubernetes-cluster.com. So you can see the load balancer now has an external service, and a record has been added to DNS. So at this point, I'm going to look at, just kind of confirm that it's there. There it is. There's a text record and an A record that was created. That was kind of fast. Sorry about that, but I was trying to squish things down so that we would have time. So we're going to create our WordPress site. And I promise this is going to go really fast. I was really typing fast when I did this. So we have a blank slate right now for a blog. What's the best thing we should do at this point? Make a backup. Let's run a backup. So we're going to do that. So now we're going to create a backup. This is going to be the site before we customized it. So it's going to be called, interestingly, MySQL-backup-1. Here are the Oracle Cloud Object Storage credentials. We're creating a secret for it to be able to connect to it. We're creating the backup. Now we're going to go back to the other screen. Watch this. So if you see in the lower right window, you can see that's where the backup happened. That's on node. That's on the third node in the cluster. Could have been any one of the secondaries. So yeah, this is where I got really fast. I drank a lot of coffee, yerba mate, and I just went to town. WordPress, you know, I just cut and pasted the README from the operator source in there. I could have done the whole ipsum lorem, but I didn't do that. So now we're going to make a second backup because, well, we've done all this work customizing our blog. Same place. Look at that. So this is the command line tool for Oracle Cloud's DNS, well, Oracle Cloud in general. So look at our backups. We have 2 of them. I'm going to describe the second one. Some information about that that's interesting. So let's connect to the cluster. That was really dumb. That was a Gomer Pyle move. Anybody know who Gomer Pyle is? I'm getting old. Yeah, you do. Okay.
Sorry, Sarge.
Golly, Sergeant. I've never truncated a table or dropped a table. Good thing there are backups. We did a backup, so we're in pretty good shape here. How's the time doing? What? So we've done a restore. Restore happened on 0 this time. That's the one from, we've got to do number 2. So let's do number 2. Create a backup from 2, bing, bong, bang, bing. Run it. Where's it going to happen? It happened on number 0. That's cool. I mean, it's so much easier than the olden days back when we were at Slashdot. And somebody's calling up, sweating bullets because things are broken. That's the beauty of Kubernetes. So to keep it going, let me bring this back up here and go into presenter view. This better not go back to the first slide. Oh, phew, good. Sometimes it does that. It's really annoying. So, yeah, I was going to show you this. This is the operator demo. That's what it's basically doing. But for this time's sake, we're going to move on to the Press Labs MySQL Operator. So this Press Labs is a company based out of Romania. They build WordPress websites, and they have a ton of data. I just really started looking into this in the last few weeks, and it's pretty interesting. It uses GitHub's MySQL Orchestrator. It's something that a friend of mine, Shlomi Noach, wrote along with several other developers. And it's basically for managing replication topology. It uses asynchronous replication. It makes use of the Percona utility user, which allows it to manage the cluster. It uses Percona ExtraDB 5.7. There's backup. Oh, actually, there's no restore. That's a slide cut and paste thing, but it does backup. They're working on restore, and it uses the custom resources for that. There are a number of containers with this. The operator itself has 2 containers. There's the operator container itself, and there's also the orchestrator container. And that connects to every MySQL instance within the Stateful Set so that it can manage it. There's 2 init containers. There's init MySQL, which sets up the configuration files, kind of like that pattern I showed you with the real basic master-slave replication. And then there's also clone MySQL. That, of course, it's pretty obvious what that does. It clones based off of the first node and does the restores. Then there's, of course, the application container. It's a Percona container, Percona database. And then there's some sidecar containers. There's a sidecar container, which does a lot of the work, just like the MySQL agent did in the previous example I showed you. It takes care of maintaining, running the cluster, and running various actions within the stateful set. There's also PT heartbeat, which just provides information back to orchestrator. And there's also a metrics exporter container to Prometheus. Here's kind of a diagram I put together to explain how this works. You can see the two init containers taking care of talking to object storage to do the clone, the sidecar container interacting with orchestrator. Actually, it's not sidecar, it connects to MySQL. That arrow is wrong. Something I did right before the talk. And of course, we have the operator, and then PT heartbeat and the Prometheus exporter. We'll do a demo of the Press Labs operator right now. And what this is going to do is show you a 3-node cluster created by the MySQL operator. It's going to show you each of the components, the MySQL orchestrator, the MySQL operator container, and in each pod within with the MySQL and sidecar containers. I'll show you the promotion of one of the slaves to master and then shutdown of the master, kind of a dumb thing to do, but it's pretty resilient. The YouTube videos for these are also online, so I'm going to do what I did before, which is play it with an external. So as before, we have a clean slate. We're going to add the repo for it, and we're going to install the operator. At this point, the operator will be coming up. Don't go! All right, so this is the name of the cluster. It has 3 replicas. And of course, it uses secrets because a sidecar container also needs to be able to talk. Also, orchestrator needs to be able to talk to the nodes. We're going to create a namespace to run this in. So we're going to look at the logs for the operator. Looks like things are working well. The next thing we're going to do is look at the orchestrator logging. You can see that it's also connected to every instance that comes up subsequently. We're also going to do a port forward. This is really nice about orchestrator, is it has a really nice UI for managing your topology. There's nothing at first. As things come up, we'll see more nodes come up. Also watching the persistent volumes as they get bound, just kind of knowing what's going on and when it's going to be ready to start operating on. We're also looking at MySQL. Things look like things are working well there. The first node is up, the master. There are no slaves attached to talking to it yet, but that'll change quickly. You can see now the second node is coming up, second pod is coming up. And then the third pod is starting to come up. Do a reload, we'll see that there's a slave connected. Third pod is coming up. And pretty soon everything will be, we'll have 2 slaves and a master. Now we're ready. So now we can do some interesting things with this. We're going to look at the sidecar container for the master. Yeah, that looks good. We're going to look at the sidecar logs for the first slave. Now the second slave, we're in business. Now we're going to go into the master. We're going to look at we're going to confirm that it is indeed a master, and it is. It's just kind of neat to see this work. For me, this like ultimate, all the times I had to manage masters and slaves and write scripts and chef cookbooks. It's all automatically done for you. So you can see that we have a master and a slave. What is the slave connected to? It should be connected to node 0. Sure enough, it is. So now we're going to promote that. Danger zone. I should have queued some Kenny Loggins on this. It would have been really cool. Like, I can't top Diana Ross, though. So, show slave status. Look at that. The node 0 is now a slave. Look how fast that was, too. Didn't have to go in there and figure out which log position we were at. Didn't have my previous boss calling me up, freaking out. It just works. So now we're going to shut it down. That's just wrong. Oh no, it's black. That means it's broken. And also the slaves are unhappy. Not to fear. Orchestrator is doing its work. It's bringing it back up. Also, Kubernetes is doing its work and bringing the pod back up. And it's happening so quickly that it's still maintaining being master. In some cases, it might take a little bit longer, and what will happen is Orchestrator will promote one of the other ones. It's kind of neat. If you do it right, you can go like through this whole cycle and see each one kind of cycling through. All right, so get back to the slides. Wow, look at that. We're at the Vitess slide. I made it. So, I got the editing view, presenter view. Okay. So, I've updated the graphics. Vitess is now a company, by the way. Vitess is a wonderful thing. It's what I consider sharding on a silver platter. How many of you have written your own sharding systems? It's a lot of fun, isn't it?
Yeah.
Yeah. 90s, that's great. We didn't even have that. Well, we had something like that at Slashdot. So Vitess is a solution for database solution for deploying, scaling, and managing large clusters of MySQL instances. It's been the YouTube database store since 2011. It's cloud ready. The cloud is coming. Somebody here sitting here told me that once. It helps you scale with transparent dynamic sharding and the ability to continue sharding in or out. Cluster management, there's tools for backups, shards, schema management. It uses the MySQL client protocol and gRPC. There's connection pooling. It has its own lightweight threads that it takes advantage of for Go. It also protects MySQL with query deduping, rewriting, sanitization. There are a number of monitoring tools built in to all Vitess binaries. If you want to migrate your MySQL application to the cloud and you're looking for something that has a really bulletproof sharding architecture, or you want to move to sharding, it's quite ideal for this. I don't have a slide for this, but Kubernetes has, one thing I wanted to stress on this is Kubernetes has really made it possible to do things that we couldn't do before. How much time? Oh, no.
Yeah, this whole I made it thing.
Is there anybody coming after this? Oh, I'm sorry. I'm really sorry. Are you sure you don't want to see the dumb? Anyway, I wish I could cover everything. It's very difficult. My takeaway in this is that Kubernetes makes it possible to do a lot of really cool things with databases, and running databases is made easier with Kubernetes. People would think, oh no, I don't have that complexity, but it makes it easier to run it. You don't have to do all of these manual steps and go through the pain that you used to go through in previous times back in the dark ages. Thank you for coming. I'm very sorry I went over.